Welcome to a tutorial on Sandia Structural Simulation Toolkit. This is a software from Sandia National Lab to serve as a framework for the simulation components of a processor, memory, and other devices you'd find in a normal computational environment. What I'm going to be working from is CentOS 6.4 64-bit edition. I've got a fresh installation that I've just run sudo yum update and yum upgrade on. So I'm going to get started here with the SST. So I don't assume that you've installed any other packages yet. With that said, we're going to install MPI and Boost. This isn't quite the instructions that you find on SST's documentation, this Google Code website, but I'm just going to assume that we're lazy and we just want to install everything from packages if possible. We're going to grab all the compilers and compiler tools necessary for SST's basic installation, which is MPI and Boost. Those are the two essential packages for SST. Alright, so now once that's installed, we still don't have MPI available as a set of commands, and so we have to run this module to be added that specifies which MPI library we're using. And then with the command in bashrc, we just make that available in the current session, so now when I run MPI run, I get all those commands available. Alright, so the next set of instructions that we're going to follow is to make this directory structure. You can actually name the initial directory instead of SST, whatever you'd like to call it. In their documentation, SST uses $home. I'm just making that $home variable the SST directory. So in my home directory, I now have the SST folder, and then within SST, there's the scratch and local folders, and all the other subfolders there. Alright, so now I have to grab Boost. There's a specific version of Boost which isn't the current version, and so we have to download the old version using wget. Once we've got that, we're going to extract the tar.gz file. It's a 59 megabyte download, so hopefully you have a pretty fast connection. Extract that out. And then go into the directory, and we're going to do bootstrap and then specify the directory. The next lines that I'm going to insert into the command window here are an edit to the project.config.jam file, specifying that when Boost gets built, it should use MPI. So this is why we first had to install MPI. Now when we build Boost, we're going to be using that MPI. So to get Boost installed, we're just going to run /b2 install, and this process takes about 30 minutes. So we'll resume this installation process when that finishes. Alright, so as you can see, time has elapsed. It's been about a little more than 30 minutes, and the Boost installation has finished. So we're going to finish this up with an ld library path variable to bash, and then reset the current environment. And now we'll have that variable available to us. Now we can get started with SST micro. So we've so far installed the MPI and Boost packages, and now we're going to change directory into our scratch location and grab the SST package. 30 megabytes, quick download, and we'll extract it. And then we're going to change into the directory that it expands. So currently we already got Boost, now we've got SST. And we'll do Autogen. Sorry. Let's see what's here first. And once that's Autogen is done, then we're going to do configure with Boost. Paste that in. So everyone's happy, and now we're going to run make all. And this will take about 15 minutes, so I'm going to come back once this finishes, and we'll run make install after this. Alright, so make all just finished, and so we're going to make install and finish up. So once the make install finishes here, I'm going to change directories into the location of the binary, and then we'll take a look at what's in there, and I can run sst.x-version. And this indicates that 3.0 is installed and functional, so that makes us very happy. And we can even go so far as to run a little test script which will demonstrate that it's functioning as a simulator. This is a simple component. This is the XML file that we're pointing at, and we're going to run that. And we just ran a random benchmark 1,000 times, and it works. So that's very good. It was run in the SST 3.0 simulator.